In this video, we're going to be finding the equation of a circle when only given 3 points. So, we've been told that points R, -2, 1, S, 4, 3, and T, 10, -5 lay on the circumference of circle C, and we've been asked to find the equation. So the first thing that I'm going to say is that it's always helpful to draw diagrams, so I'm going to do that quickly. It's a very wonky circle, but it's calm, it gets our point across. So the first thing that we're going to do is we're going to connect these points. So we're going to call this line RS L1. And we're going to call the line ST L2. So we're going to use the fact that perpendicular bisectors of chords are going to cut through the midpoint of the circle. So essentially, if we take the perpendicular bisector of L2 and the perpendicular bisector of L1, the point where they intersect, because they both cut through the center, is obviously going to be the center. So the first thing that we need to do is find the gradient of our two lines. So M of L1, so remember the gradient formula is going to be y take away y1 over x take away x1. If we just write our two coordinates that we're dealing with, so R and S, we have our points R, -2, 1, and we have S, which is 4, 3. We can call this X, Y, X1, Y1. So then just substituting into our formula, we get M of L1 is going to be equal to Y, which is 1, take away Y1, which is 3, divided by X, which is -2, take away X1, which is 4. So simplifying this, we just get -2 over -6. Then that just goes, obviously the negatives will cancel out and the common factor is 2. So we can just divide root by 2. So we get the gradient 1/3. So now for the gradient of L2. So we're going to say M of L2 is going to be the exact same thing. So the gradient is going to be Y take away Y1 over X take away X1. We're going to write our sets of coordinates. So we have S, which is 4, 3. And we have T, which is 10, -5. We're going to call this X, Y, X1, Y1. And really, it doesn't matter which you put. So this can be X1, Y1, this can be XY. It doesn't matter. It works out to be the same thing. But anyways, so substituting in, we get Y, which is 3. Take away Y1, which is take away 5, which is just going to turn into a positive. So it's going to be 3 plus 5 over X, which is 4. Take away X1, which is 10. So we're going to get 8 over -6. Then we can see that 2 is a common factor. So this is going to be -4 over 3. So we have our gradients now of our two lines. So we can write the gradient of L2 is going to be -4 over 3. And the gradient of L1 is going to be 1/3. Now, we also know that a perpendicular gradient is going to multiply with the gradient of a line to produce -1. So therefore, we can take the negative reciprocal of this. So if we draw two more lines, let's call this L3 and this L4. So we're going to say if ML1 is equal to 1/3, that must mean that the gradient of L4, so therefore the gradient of L4 is going to be the negative reciprocal. So flipping it over and putting a negative sign, it's going to be -3. Likewise, if the gradient of L2 is -4 over 3, we're going to know that the gradient of L3, so ML3, is going to be the negative reciprocal, which is going to be 4 over 3. So now we have the equation, the gradients of these two lines, but we still don't know where they intersect here. And to find the equations of L3 and L4, we need to know a point on the line. So we're going to work out here, and we're going to use the midpoint formula. So we're going to say that the midpoint formula is just going to be equal, the x coordinate is going to be x plus x1 over 2. And then y is going to be y plus y1 over 2. So then just substituting in like we done here, we're going to take our two coordinates, label them, substituting. So midpoint, so I'm just going to label that as a m dot. So m dot rs, which is from r to s, so L1, is going to be equal to, then we're going to write down our sets of coordinates that we have. So r, I'm going to write it here, r is -2, 1, s is going to be 4, 3. We're going to call this x, y, x1, y1. So then substituting in x, so -2 plus x1 plus 4 divided by 2. Then our y coordinate is going to be y, which is 1, plus y1, which is 3, over 2. Then simplifying that, we get -2 plus 4, which is +2, divided by 2 is just 1. So we're going to get 1, and then 1 plus 3 is 4, divided by 2, that's 2. So we know that this point here, I'm going to put there, is going to be 1, 2. So then doing the same for L2, so line ST, so m dot st is going to be the same. So we're going to label our sets of coordinates. So we're going to have s, 4, 3, and t, 10, -5. Going to label it x, y, x1, y1. We're going to substitute in. So x, 4 plus x1, which is 10, divided by 2. And then the same for the y. So y, which is 3, plus y2, which is -5, divided by 2. Simplifying that, 4 plus 10 divided by 2, that's going to be 7 divided by 2. 14 divided by 2, which is 7. And then 3 plus -5, that's just going to be -2 divided by 2, which is -1. So we're going to know that this point here, I drew it a bit higher in the diagram, but it's cool. It's going to be 7, -1. So now we're going to write the information that we have less relevant. So we're going to know for L3, you know that the gradient is going to be equal to 3/4. And we're going to know a point on the line is just going to be here, st. So 7, -1. And then we're going to do the same thing for L4. So if we do that, so L4, we're going to know that the gradient is going to be -3. And the point on the line is going to be 1, 2. So now we can find the equation of these two lines, and we can use that, and we can do that by using the equation y take away y1 is going to be equal to mx take away x1. So basically what we've done before, setting our coordinates, giving them names, substituting in. So we're going to call this x1, y1, and we're going to do L3 first. So L3, y take away y1, which is -1. So y take away 1 is just going to be y plus 1. It's going to be equal to m, so 3/4. X take away x1, which is 7. So then we can simplify this. We want to get into the form y equals mx plus c, so we can find the center, because that's a part to finding the equation. So simplifying this, we get y plus 1 is going to be equal to 3/4x, and then we're going to get -21/4. Then taking 1 away from both sides, we get y is equal to 3/4x, -25/4. So our equation for L3 is going to be this. This here, I made a mistake, so let's just do L4 again. So L4 is going to be y take away y1. So y take away 2 is going to be equal to -3, x take away 1. Then simplifying that and putting into the form y equals mx plus c, we're going to get y take away 2 is going to be equal to -3x plus 3. Then adding 2 to both sides, we get y is equal to -3x plus 5. Then finding the point of intersection between the 2 points. Let me just circle this again. So finding the intersection between the two lines, we're just going to set them equal to each other. So we're going to say 3 over 4x take away 25 over 4 is going to be equal to negative 3x plus 5. Then multiplying 3 by 4. So 3x take away 25 is going to be equal to negative 12x plus 4 times 5, so that's plus 20. So then collecting like terms, we can add 12x to both sides. So we get 15x. Adding 25 to both sides, we get 15x is going to be equal to 45. Therefore, x is equal to 45 over 15, which is equal to 3. Then to find y, we can substitute back into any of our equations, but it's probably easier to substitute into the... So then y is equal to negative 3 multiplied by x. So negative 3 times 3 plus 5. So if we do this in our heads, negative 3 times 3 is negative 9 plus 5 is negative 4. So it's equal to negative 4. Therefore, the center of the circle is going to be at x equals 3 and y equals negative 4. So now that we have our center, all we need to know is our radius. And we can do that by finding the distance from the midpoint. So I'm going to label this here 3, negative 4. We find the distance to one of the points in the circumference. So let's say from the center to point R. So we have our center here. So then let's write R is negative 2, 1. So then finding the distance between the 2 points, we can just use the distance formula. So d is going to be equal to the square root of delta x squared plus delta y squared, where delta x is going to be equal to x take away x1, and delta y is going to be equal to y take away y1. And then the same thing that we've been doing throughout, we're going to label our sets of coordinates and substitute in. So let's call this x, y, x1, y1. So then substituting in, delta x is going to be x, so it's equal to 3. Take away 2, which is just going to turn into a plus, which is equal to 5. Delta y is going to be y, so negative 4 take away y1, take away 1 is going to be equal to negative 5. Therefore, the distance from the center to R is going to be equal to the square root of 5 squared plus negative 5 squared. And if we do this in our calculator, we get 5 root 2. So this is going to be our radius of the circle. And we know that a circle, the general equation, is going to be x take away a squared plus y take away b squared is equal to r squared. So another thing that we should know is that 5 root 2 is going to be the same as root 50. So then, this should be r squared. So if we put our center and our radius into here, we're going to get x take away 3 squared plus y take away 4 squared is going to be equal to root 50 squared. Then simplifying that, we just get x take away 3 squared plus y plus 4 squared is equal to 50 for our equation of the circle.